Okay, this project is about the setup of a large-scale network simulator with CorNet, and the main work I have done include first I'm gonna give a brief introduction of the task, the problem which I've been facing, and second I will talk about the network topology, how these computers and servers are organized. And third, I'm gonna talk about the router setup. And finally, I'm gonna talk about the core of this project is to set up RVIP protocols. Um, the the problem I'm facing is that there are a couple of individual RVIP subnets, and how to set up the network structure to accommodate this RVIP subnets in order to enable them to talk with each other freely. So the problem is how to make the interconnection between different RVIP subnets. Okay, in terms of the network topology, we have 10 servers, and each server has IP address from 10.13.16.33 to 10.13.16.42, and all of these servers are interconnected by the switch. So they share the same subnet mask, which is 255.255.248.0. And the problem is we have to set up routers on each server which can connect a virtual network through this router and connect it to another virtual network. And finally, this traffic all goes through this the shared switch, and the traffic can reach to other virtual network. And this problem becomes a little bit challenging because we have to set up the virtual routers on each server, and the virtual network which is simulated by CorNet, the RVIP protocol, is also have to be connected with the router, and this router has to connect to the server. So these routers have separated the subnet into a few. For example, the router 1 has separated the 10.13.16 subnet from 10.13.24 subnet, and the second router has 10.13.32 subnet, etc. The ninth router has 10.13.88 subnet, and finally the last one has 10.13.96 subnet. So actually we have 11 subnet. All these servers share one subnet, and the other end of a router share an different subnet. So this virtual network are connected into their distinct subnet. Okay, the first and foremost thing is to set up a router. The router, actually we didn't use any actual hardware routers. We use software routers on virtual machines. So the software router we installed is called Quagga. And Quagga consists of several core daemons, which we usually call services on Windows platforms, but we call daemons on Linux. These daemons include Zebra, which provides the basic interface functionality of Quagga, and BGPD provides BGP routing protocol, and OSPFD provides OSPF routing protocol, which we have been used in our setup. And RIP-D is RIP version 4 routing protocol, and RIP-NGD is RIP IPv6 routing protocol. In this setup, we just only use Zebra and OSPFD. So For Zebra, we have this kind of uh, router table setting up script. The first line and this line have specified the interfaces we're gonna use. We use in our system. The interface li, which represents loopback, we can just ignore this line because the loopback we didn't use loopback. And the interface ETH0 is the network card we have installed on this server. No, it's not the server. It's a virtual machine. So we give the IP address of 10.13.48.11.011 for this router itself, just for the router, and they have the 21 subnet mask. Also, another interface, which is ETH1, is we also assign the IP address 10.13.56.137 with the 21 subnet mask. Also, the IP forwarding is the most critical setup. We should keep it open. Okay, this is a Zebra, which Zebra specifies the basic interface we use in our setup, and OSPFD specify the specific router setup for their interface. For example, we have interface ETH0 and ETH1, and these two interfaces are connected with the OSPF protocol. So first, we have set up the network area 0, the backbone area, for IP address 10.13.48.0 with 21 subnet mask. And another area is also connected to the OSPF protocol, which is 10.13.16. And this redistributed connected command specifies we can use the Zebra configurations to initialize OSPF daemon. Okay, after the router has been set up, the next step is to set up the RVIP. The RVIP actually consists of two levels, level 1 and level 2. Because the limitation of this time to finish this project, I primarily focused on level 1 setup. So the level 1, simply put, just creates a tunnel to conduct traffic between real and virtual interfaces. So level 1 is not as realistic as a real router protocol. The advantage is that it is very easy to implement and set up for simple case. We have to mention that this level 1 is just suitable for a simple case. You just connect to a few number of computers on this virtual network, and this real machines were mapped into the virtual network. So in this case, level 1 works perfectly. But if you want to connect, for example, this pretty complicated network, level 1 is not gonna work pretty good. So I'm gonna talk about this later. So of course the limitation of RIP level 1 is that it has no support for real routing protocols. So if you just wanna to transfer data from one computer virtual real to another computer virtual real, and if they are directly connected to the virtual network, it works. It definitely will work because this computer A can be mapped into a virtual node in a virtual network, and the computer B can be mapped to a virtual node, another virtual node in a virtual network, and they have their different IP addresses. So everything can be done inside the virtual network. So this is what our IP level 1 does. It does not encapsulate any routing protocol for outside real network. So if these two computers are not directly connected to the virtual network, they are connected, such as just as this case, they are connected through routers, through switches, and through different and span across different servers. In this case, RVIP version 1 doesn't work pretty good. It does. It can achieve certain amount of certain kind of functionality, but it cannot work perfectly. So we have to resort to RIP level 2 to support any complex real routing protocols. RIP level 2 is pretty much more complex structure than level 1, and it also has the basic advantage that it can connect the arbitrary multiple subnets and very complex network together, because RVIP level 2 really supports kinds of routing protocols such as OSPF or any other. So, but I didn't make any investigation into level 2 right now, but I plan to investigate what level 2 looks like. So it's the future work, I think. Okay, that's all for this presentation. Next, I'm gonna shift to the demo of how the project was done. Okay, let's get started with the demo. First, this is a Linux machine. I have, of course, it's a virtual machine I've used to manipulate and configure the remote machine on the host server. First, let's get started the terminal and get it maximized. Just SSH 172.16. You can use any of the 10 servers. I just use the last one because I have the configuration file for the last one. Anyway, you can use any. There is no difference because all these host servers share the same file system, the user file system. So let's log in. So let's take a look. Yeah, this on this machine we have a virtual interface which is VBoxNet9. The IP address is 10.13.96.1. You can set this IP address at any value, but I just set it like this. And this machine also has two real interface, actually three, ETH0, ETH0 and ETH1. They have a different IP address. You say this is a 172. This begin with 10, so there are different network. And they have also a super fast IP0, which is infinity band. I don't really know. I don't think we're gonna use this. So the trick is we have set up the VBoxNet9, which is a virtual interface set up by the VirtualBox. So we're gonna use this virtual interface to interconnect two virtual machines, and these two virtual machines communicate with each other through the RVIP tunnel. So I'm gonna show you. Before I show you how the RVIP works, I'm gonna first show you the setup of the routers. Let's first take a look at the routers. I have 10 routers from 33 to 42, and these routers can be accessed through remote desktop connections. You can ask any routers. For example, you can ask 33. Yeah, this is router, and its IP address is 24.101 and 16.133. They are at different subnet, of course. And the Quagga configuration has been set up already. So just let this router run for himself, and check out the routing table. You can see this is the 33 router. So it has 134, 135, 136, 137. All these routers are connected. This is OSPFD's work. You just set the network area, and the OSPFD will help connect for you automatically. Okay. Okay. To run the RVIP, you have to change first to the root privilege. Let's change to root. Okay. Then we change to the folder where the RVIP kernel resides. Scenario, it's real, level 1. Let's continue. Yeah, and we run Cornet with this preset. Let's first take a look at the setup. Yeah, we can see that we have two real interfaces in the RVIP tunnel, which connected to VBuxNet 9, and the IP address for node, they are node number 1 and node number 4. The IP address for node number 1 is 10.13.96.101, and the IP address for the number 4 node is 10.13.96.200. Which this means is that these two nodes, which are virtual in a cornet, will be mapped to a real node, which I use virtual machine to set up, to these two IP addresses. So these two IP addresses are the real machines I drive as virtual machines IP address in cornet. Okay, let's get started. And first, let's open these two real node. 4257. Yeah, this is machine 1, and this is machine 2. Let's check up. Yeah, this machine has one network card which has an IP address of 10.200, and this machine has 96. This is let me see. Yeah, it's 96.200. This is 96.101. The routing table. Sorry. Routing table. It's 96. We reach 96.101. This machine through gateway 96.1, which is a VBuxNet 9's IP address. So we just we mimic the scenario where these two virtual nodes are mapped to these two real machines through the virtual interface, which is also a real interface here, which is also regarded as a real interface. So Yeah, we check the routing table of this machine, and we can see we've already set up the 96.200 goes through the gateway 96.1. This is 96.1. Yeah, and we try to ping this machine's IP address, which is 96.1 10.13.96. We can see it's not pinnable and it's not connected. We ping this machine, ping what's 90 IP address 96 200. Yeah, you can see they are not connected, so they cannot communicate with each other. The traffic is blocked. So here we're gonna start the RVIP engine. Okay, the RVIP starts to scenario. In this case, you can see it's connected. The traffic of ping can go through RVIP to another machine, and another machine can go through the RVIP to this machine, and it just keeps pinnable, and everything works fine. Yeah, I'm gonna stop. So we can say that this machine has 28 packets, and this machine has 25 packets. So the total packets going through this RVIP is 53. Let's get aboard. So we can see the RVIP data 1 has sent 53 packets, and another one is 52. So it's just proves that almost all the packets have gone through this RVIP tunnel. So that's it. That's the project demonstration of the work I have done in the past few weeks. Thank you.